In recent months, Fish and Wildlife, Fish and Game, and environmental NGOs have theorized that increases in the Caspian tern in the Columbia Basin in the state of Oregon has been a causative factor in decreased salmonid production as they predate upon salmonid smolts. Salmonids compose 73 to 90% of the Caspian tern's diet. Rather than considering thinning of the tern population, they are proposing relocating some of them throughout the Washington, Oregon, Idaho, California, and Nevada. The rationale behind this proposal is insanity, as the relocation and building of new habitats for the tern would seriously affect present ecosystems in addition to allowing them to continue populating new areas for these predatory birds. As has previously been presented, the causative factor in decreased commercial salmonid production in Washington, Oregon, and California is the increased warming of the Pacific Ocean, driving cold water salmonids north into Alaskan waters. Another aspect of the salmonid controversy is that with the increased numbers of salmonids in Alaskan waters, there is concern that there are too great a number of them and that there may not be enough food for these increased numbers, and they are proposing that perhaps hatcheries should be shut down or seriously decrease their production. With the planting of salmonids in California in 1895 and multiple subsequent plantings, in addition to the erection of dams and hatcheries in the Pacific Northwest, by 1950 the total landing of all species of salmonids was 149,000 metric tons, with 80% caught in Alaskan waters. With continued hatchery production in 2007, the total landings was 403,000 metric tons in the Pacific Northwest, with 97% caught in Alaskan waters. From the standpoint of commercial fishing, the production of salmonids is a positive human intervention with a 273% increase since 1950. However, the serious decline of commercial salmonid production in the states of California, Oregon, and Washington have been attributed to the very human intervention that has proved successful for commercial salmonid production for over 100 years. At present, Fish and Wildlife, Fish and Game, and environmental NGOs are proposing removal of dams and hatcheries, which they theorize that salmons will return to historic spawning grounds and increase production. The reality is that without dams and hatcheries, there'd be little salmonid production in the Pacific Northwest, as historic data demonstrates. An in-depth study of river and ocean conditions has been undertaken, and it must be noted there has been a historic rise in the temperature of the Pacific Ocean, driving cold water salmonids north into Alaskan waters. Since the 1700s, we have not seen such a warming of the Pacific Ocean, and the graphic representation clearly illustrates a historic rise since the early 1970s. In an attempt to understand this temperature rise, it was discovered that there's been a comparable rise in the Ring of Fire volcanic activity since the early 1970s. It was also discovered that planetary earthquake activity and heat content of the Pacific Ocean have also increased dramatically since the early 1970s. The graphic representation states it clearly. There is no foundation for theorizing that removal of dams or hatcheries will restore salmonids in California, Oregon, and Washington states. The decrease of salmonid populations in California, Oregon, and Washington states is as a direct result of a historic rise in Pacific Ocean temperature, driving salmonids north into Alaskan waters. Removal of dams and hatcheries and relocation of Caspian terns will not restore salmon fisheries, but will ultimately destroy the Pacific Northwest commercial salmonid fisheries. It is apparent that the temperature rise in the Pacific Ocean, volcanic activity in the Pacific Ring of Fire, global earthquake activity, and increased heat content of the Pacific Ocean are the result of a planetary cycle, and dams or hatcheries cannot be blamed for reduced salmonid runs in Washington, Oregon, and California. Thank you for listening.